expressions, it's important to remember that you're actually going to factor first. So this is an example of a rational expression. You have a polynomial in the numerator, a polynomial in the denominator. What we're going to do is factor the top as if it was alone, and then we're going to factor the bottom as if that was alone. After we factor the top and the bottom, we should be able to cancel something within our fraction. So again, the idea behind simplifying rational expressions is that you must still factor. You first factor the numerator, then you're going to factor the denominator, and then you're going to cancel. So let's take this example and follow our own steps. In the numerator, we have a trinomial where the leading coefficient is not 1, it's 2. So that means we're going to follow our specific set of rules for helping us factor a trinomial like this. So our rules for factoring trinomials where the leading coefficient is not 1 is to multiply the first and the last term, which gives us 6. The second step is to list factors of that number, which will be 1 and 6 and 2 and 3. The third step is to choose which combination of factors we want to use to get 5. Initially, when you look, you might say 1 and 6 or 2 and 3 could work. So let's just try 1 and 6 first. Now that we've chosen the factors that we're going to use, let's rewrite this trinomial with 4 terms so that we can factor by grouping. So now we're going to write 2x squared, and instead of using 5x, I'm going to represent 5x using 1 and 6. Since I want my middle term to be positive, that means my largest number needs to be positive. So 1x, subtract a 1x, and add a 6x, because when I simplify negative 1x and positive 6x, it gives me a positive 5x. And I'm just going to bring down the minus 3. Now that I've rewritten the trinomial as a polynomial with 4 terms, now I can continue to factor by grouping, which is why I rewrote it this way in the first place. So in the first binomial, I see that there is an x in common. When I take out the x, when I divide each term by x, I'm left with 2x minus 1. In the second terms, I see that they have a 3 in common. So when I divide out the 3, I'll be left with 2x minus 1. Since I got the same binomial factor in both terms, I know I'm headed in the right direction. So in order to finish factoring by grouping, I'm going to take out the common factor, which is 2x minus 1, and my second binomial factor is going to be what's left, which is x plus 3. So the numerator. So instead of writing 2x squared plus 5x minus 3, I'm going to write the answer that I found after I factored, which is 2x minus 1 times x plus 3. Now that we've factored the numerator, it's time to factor the denominator. When we look at the denominator, negative x squared plus 9, it does look kind of familiar. It almost looks like the difference between two squares. The only thing that's missing is the difference. So what can we do to this polynomial to change it to the difference of two squares? Well, if you factor out a negative 1, negative x squared will become positive x squared, and positive 9 will become negative 9. Now I have a factor of negative 1 and a factor of x squared minus 9. Now when I look at the factor x squared minus 9, I can see that that can still be factored. So what you want to do is rewrite your numerator, just bring it down, and you want to continue to factor that difference. And the way that you factor the difference between two squares is 1, you know that the answer is going to have 1 plus and 1 minus, and 2, x squared can only be found by multiplying x times x, and 9 can be found by multiplying 3 times 3. So now I have factored the numerator and factored the denominator. Now the next thing you need to do is look for common factors in the numerator and the denominator so that you may cancel. Right away you can see the numerator has x plus 3, and so does the denominator. So my final answer is going to be what's left. What's left in the numerator is 2x minus 1. What's left in the denominator is negative 1 times negative x plus 3, which if you multiply that out, negative 1 times x gives you negative x, and negative 1 times negative 3 gives you plus 3. And that would be my final answer for the first one. There's a lot of side work involved. Sometimes you need to go do the work on the side and then go back to your original problem and finish the problem. So let's look at the second one. The second one's a little bit easier. We don't have any trinomials here. We just have two binomials. So again, you want to factor the numerator and then factor the denominator and then look to see if you have anything in common that can be canceled out. In the numerator, 3x plus 18, it's not a trinomial, so I'm not going to factor it the same way. But one of the first things we learned when we were factoring is that you should always, always, always look for a greatest common factor. And factor in 3x plus 18 is the number 3. So when I factor out the number 3, what's going to be left is x plus 6. Now let's factor the denominator. Again, I have the difference between two squares. Anytime you have the difference between two squares, you know they're going to have one with a plus sign in the middle and one with a minus. The square root of x squared is x times x. And the square root of 36 is 6. There's now I've factored the denominator. So now that I'm done factoring the denominator, we need to look for something that's the same so that we can cancel. Right away you see that they both have an x plus 6. So after you cross that out, your final answer is going to be what's left, which is 3 over x minus 6. Now we are going to solve quadratic equations. When solving quadratic equations, you must factor first, just like always. Still need to factor, but again, there's an extra step that will take place. To see what the difference is between simplifying polynomials or factoring polynomials and solving quadratic equations, let's look at the following example. What is the difference between these two problems? As you can see, they're both the exact same polynomial. The only difference is this problem does not have an equal sign or a 0. This problem does. This is what we've been doing. What we're going to start doing is solving quadratic equations. And what makes this an equation is the equal sign. The funny thing about it is that in order to solve this, you still have to factor first. So the difference between these two problems is the equal sign. Like I said before, there is only one extra step you must perform in order to solve this quadratic equation. You still must factor first. So let's factor this problem. X squared minus 4x minus 5. Right away, I know the only way I can get x squared is by multiplying x times x. This sign right here tells me that I'm going to have opposite signs inside of my factors. Now all I have to do is think of what's going to be in my last term. And that I can look at by finding the factors of 5, which are only 1 and 5. Now, how do you decide which one's going to be positive and which one's going to be negative? Well, since my middle term is negative, my larger number to be negative too. So now I've factored. So in the previous problems, you would be done right here. But now since we're solving, there's one more step. So after you factor, you must set both factors equal to 0. So x plus 1 is my first factor and x minus 5 is my second factor. So this is going to yield two answers. So let's set them both equal to 0. X plus 1 equals 0 and x minus 5 equals 0. Once you have actually 0, now both your factors equal to 0, now you must actually solve for x, just like we did in the beginning. So in order to get x by itself, you need to subtract 1 on both sides. Here you get an x equals negative 1. And over here, in order to get x by itself, you need to add 5. So here we get x equals 5. So my final answer is x equals negative 1 and x equals 5. Let's try one more problem like this. Here we have 3x squared minus 11x plus 10 equals 0. Since the leading coefficient is not 1, we have a set of steps we need to follow in order to factor this kind of problem. The first step is to multiply the first and the last number, which gives us 30. The second step is to list factors of 30, which would include 1 and 30, 6 and 5, 2 and 15, 3 and 10. Those are some factors of 30. So out of those factors, which one will give me 11? 6 and 5 seems to be the obvious choice. Now that I've actually found the ones that I want, I need to rewrite my polynomial as with 4 terms instead of 3. So I'm going to write 3x squared, and I'm going to substitute negative 11x with 6 and 5. So I'm going to have a negative 6x and a minus 5x plus 10 equals 0. Now I can continue to factor by grouping. So when factoring by grouping, we group the first 2 terms and the last 2, and we begin to pull out the GCF. 3x squared minus 6x has a GCF of 3x. So when we take out 3x, let's see what's left. 3x squared divided by 3x leaves me with an x, and a negative 6x divided by 3x leaves me with a minus 2. Let's look at the second set. I have negative 5x plus 10. Since I want my binomial to have an x minus 2, I'm going to divide by negative 5. So as negative 5x divided by negative 5 is going to give me a positive x, which is exactly what I need. And positive 10 divided by negative 5 is going to give me a minus 2. Again, exactly what I need. Now since both of these have this common GCF here, that's the next thing that we're going to pull out. So when we take out the greatest common factor, x minus 2, you write what's left in the second binomial, which is 3x minus 5. Now here again, normally is where you would be. We're solving quadratic equations. You want to set each factor equal to 0 and solve. So you have x minus 2 equals 0 and 3x minus 5 equals 0. In order to get x by itself in the first binomial factor, you're going to add 2 to both sides. So here you get x equals 2. Now on this one, to get x by itself first, you need to add 5 to both sides, which cancels the 5. You'll be left with 3x equals 5, and you still want to get x alone, so here you need to divide by 3. So you get x equals 5/3. Now don't worry about the fact that you have a fraction as an answer. It's allowed to be. You have 2 answers, x equals 2 and x equals 5/3.